everyone. Now we will discuss the experiment 1. So from the table below we can see some materials and results from the observation. Okay, so first we need to know what is hazel cyanoferrate. Hazel cyanoferrate is used to detect the Fe2 plus ions. Hazel cyanoferrate will produce a blue color in the presence of Fe2 plus ions. Meanwhile, for the phenolphthalein is used to detect hydroxide ions. Phenolphthalein will produce a pink color in the presence of hydroxide ions. So first of all, when zinc 2 plus react with hazel cyanoferrate, it will produce only white color because there is no presence of Fe2 plus. So the second one, Fe2 plus react with potassium with hazel cyanoferrate to produce a blue precipitate. And then the last one, because there is presence of hydroxide ion, phenolphthalein will change color from colorless to pink. So from the below equation, we can see some of the reaction. There are some oxidation, reduction that happens in the experiment. So for the next experiment, which is experiment 2, I will call a good friend of mine to explain about the experiment 2. So wait. Hello Anas, it's your turn now.
Hello, Usha. Okay, thank you. Okay, previously you have just heard from the Michelle about the explanation of experiment 1. And then, now I will continue for the experiment 2, which is the corrosion in the gel experiment. And there are some information given to me as below. And then I have provided the video for you guys as the support document for me to explain about the experiment. And if you want to watch this video, you can also type this link that I have attached in the slide. And then without wasting our time, let's watch it. To give a credit to a faculty of civil engineering of the Rochen University for providing this video to make me more easy to explain. Okay, first we have agar gel and the potassium nitrate and potassium cyrophenate. And then we have iron in contact with silver, iron in contact of iron oxide, and the pure iron as a constant variable. And then we heat the hot water to make sure that we can mix with the agar gel more perfectly. And then we add some potassium nitrate to promote the indication of the iron ion. And then we add some potassium cyrophenate, and the pH indicator that has been used in this experiment is the phenolphthalein to indicate the pH of the water or the solution. And then after we have done mixing all the solution, we put the solution into every single container containing all the nails in the previous video. And then we wait for the several days to make sure the experiment occurs perfectly. And then there are several coloration, which is blue, that indicates the presence of a ion due to corrosion, and the purple colorations indicate the OH minus ion. And then there are some of the redox equation, or we can say as a half equation of the corrosion. And I think that's all from me. Hello Hatim, my part is done, and you can take over.
No worries, Anas, I got this. Do you know why boat builders attach zinc blocks to the ship's hull? It is actually because zinc coating being used for an efficient solution for marine and offshore corrosion prevention and cathodic protection. The hull of a ship is the watertight body that is exposed to water. To protect the hulls, the ship builders put pieces of zinc on these hulls. The zinc components used on these ships are called the sacrificial anodes. Sacrificial anodes are linked electrically to the ship's hull. They are made of metals more reactive than the material used for the ship's body and systems. As such, they shield the ship's body and systems while the ship stays protected, giving the rise to the name sacrificial anodes. Zinc is used because it has a higher voltage in water, so the current is more inclined to flow from it than from the propeller. To complete the electrical circuit, zinc components are connected to the items they are intended to protect only. Zinc is bolted right to the shaft or the underwater housing of the ship. Non-metal boats usually have a copper bonding wire inside that connects all the underwater metal items together, so they all share the protection from the zinc anodes. Zinc sacrificial anodes are also used for subsea structures such as pipelines, wind turbine foundations, and water storage tanks. Using sacrificial anodes gives a multitude of benefits, such as capacity to last and provide effective cathodic protection for up to 25 years, no maintenance requirement, very high reliability, no hull penetrations, zero risk from interference, and lower overall life cycle costs. You can use some of this too, you know, you need it.
Hello, now we will talk about question 2a, which asks us to explain the process of this diagram. As we can see, zinc SO4 is used as an electrolyte of this experiment. Therefore, the ion present in it is zinc 2 plus, H plus, SO4 2 minus, and OH minus, and it is an aqueous solution. We can see that the anode of this experiment is plate of zinc, while the cathode is plate of iron. During this experiment, zinc at the anode will dissolve by releasing electron to form zinc 2 plus ion. This process is called oxidation process. While at cathode, zinc 2 plus will accept electron to form zinc atom, and this process is called reduction process. At the end of the experiment, we can see that zinc metal will be deposited at the plate of iron. Some may be asked why OH minus and SO4 minus will not discharge at the anode. This is because zinc is used as the electrode for this experiment. These are half equation which happens during this experiment, which at the anode, zinc will plus with 2 electron to form zinc 2 plus, while at the cathode, zinc 2 plus will form zinc atom plus 2 electron. In this experiment, we can see that plate of zinc will become thinner and thinner, while plate of iron will have shiny metal deposited at it.
Let me continue with the question 2b. You may pause the video to read the question. So based on the question, we can take out the information, which is area, thickness and current. And by using area and thickness, we can calculate the volume, and this is the solution. First step is we must find the mass. So to find the mass, we must use the density formula, which is density is equal to mass over volume. So we arrange the formula and we can get the mass is equal to density times with volume. So we substitute the density given and volume, and we can get the value 7.133 kilogram. Next, we must find the number of mole. Number of mole is equal to mass over molar mass, and substitute the mass and molar mass given, and we will get the value of number of moles. Then we can calculate the moles of electron, which is 2 times number of moles, and these are the solution. After calculate the moles of electron, we can use the formula Q is equal to Fn to find the charge, and these are the solution. After we get the value of charge, which is Q, we can use the equation Q is equal to IT. We can rearrange the formula to get T, which is equal to Q over I. Substitute the Q and I, and we will get 21,056.4 seconds. Then we can convert it into hours, which we will get 5.849 hours. So we can conclude that the duration of the electrolysis is 5.849 hours.